In this video, we will explain the growth and decay word problems. First, we need to understand the formula. The growth and decay formula is y is equal to c e to the power of kt, where y is the final amount, c is the initial amount, k is the constant rate per unit of time, and t represents the time. Here's an example. A certain strain of bacteria population decreases from 326 to 40 in 120 minutes. That means 2 hours. Find the value of the rate of the decay, k. First, we know y is equal to c e to the power of kt. Okay, so y is equal to 40 and c is equal to 326 times e to the power of kt. We know it is t is 120 minutes, so that is going to be 120 k. We need to find the value of k. So 40 over 326 is equal to e to the power of 120 k. Apply a natural logarithm on both sides will give you ln 40 over 326 is equal to 120 k ln e. Doesn't make any difference. This part right here is going to be just 1. So k is equal to ln 40 over 326 divided by 120. That is approximately negative 0.02. You know, that is bacteria per minute. The second part of it, how long does it take the bacteria to reach its half-life? So half-life is just 1/2. It is half-life is as reaching the whole part to its half. So 1/2 is equal to 1 times e to the power of kt. We can use the value of k from the previous section right here, so that will give you let's apply the natural logarithm. ln 1/2 is equal to kt ln e, which is again 1. So we know t is equal to ln 1/2 divided by actually k, but we know k is negative 0.02. By using a graphing calculator, t is approximated as 39.65 minutes. So that means it will take about 39.65 minutes for the bacteria to reach its half-life. Here's another question about the half-life. The half-life of a radioactive substance is 21 days, and there are 4.62 grams present initially. When will there be less than 1.5 grams remaining? To start with, we can just set up the equation. 1/2 is equal to 1 times e to the power of kt, which is 21k. We know t is 21 days, so take the natural logarithm on both sides. ln 1/2 is equal to 21k, and k is equal to ln 1/2 divided by 21. Now let's look at the second half of the problem. When will there be less than 1.5 grams remaining? We need to find the time takes to reach the radioactive substance with the 1.5 grams remaining. Okay, so we will set up the equation. We know the final amount is going to be 1.5 grams. Initial amount is 4.62 grams, e to the power of kt, the same formula that we used before, and 1.5 divided by 4.62 is equal to e to the power of kt. Apply a natural log on both sides, so it will be 1.5 divided by 4.65 is equal to kt, or t is equal to ln 1.5 divided by 4.65 divided by k, but k is this quantity right here, so that's going to be ln 1/2 divided by 21. Using a graphing calculator, the time is calculated as Using a graphing calculator, the time is calculated as Using a graphing calculator, the t is approximated as 34.08 days. So that means the 4.62 grams will reduce to 1.5 grams in 34.08 days. Thanks for watching.